So, hello everyone, so I'm Hanson. So today I'm going to teach you all Mathematics Form 3, Chapter 6. So in this video, you're going to learn about the angle and tangents of circle. And I hope you all learn a lot and enjoy this video. Alright class, so before we begin, do you have any ideas about this topic? And how do you use the angle of circle in your daily life? Just comment on this video, alright? So let's start with our introduction. Okay, class, do you know that circle have a unique shape and have a special properties? Its specialties allows circle to be used in various fields, and the concept of angle and tangents of circles are used in industries, road constructions, painting, astronomy, sports, and many more. So, class, do you know shot put? Shot put is an athletic event. The shot put area is circular. As you can see from this picture or image, the shot put area is circular with diameter of 2.135 meter, and the circle is divided into two semicircles, which is, as you can see from the pictures, there are two semicircles and with a white lines of 50 millimeter thickness. And as you can see from the image also, there are two straight lines are drawn from the center of the circle at the angle of 34.92 degrees between each other to determine the shot put area. Therefore, this athlete have to throw the shot put within this area to gain points. Okay, let's move to our first subtopic, 6.1, angle at circumference and center angle subtended by an arc. Okay. Alright, so before we move on, let's make a short flashback about what we have learned about circle during Form 2 or during your Form 1, alright? So first, on this circle we call it the circumference. Next, as you can see, there's a dot at the middle of the circle. We call that the center of the circle. Right, next, so as you can see, there's a line that connects the center of the circle to the circumference. We call that the radius. Next, there's a straight line from the points of the circle pass through the center of the circle and end at the other points of the circle. We call it diameter. Next, as you can see, there's a one point of touches the circumference and end at the other points of circumference. We call it chord. Alright, next, draw two radius, and from this area, we call this area is minor sector, and from this point to this point, we call this minor arc. How about this area? I guess you might already know, which is the major sector. And from this point to this point, we call it the major arc. Alright, so the angle at the circumference. Let's say draw a circle and draw an angle EFG. So this angle, we call it angle of EFG, and from this point to this point, we call it arc EG. Therefore, you can say that angle EFG is the angle at circumference of the circle subtended by arc EG. Okay, alright. So after the brief through, let's go for short quiz activity, right? So it's required only 4 members in each groups, and gain mini score as you can. You might click the link on the video descriptions to start the quiz, and I'll give you 10 seconds to pause this video. Alright, class. So this is the quiz activity that I asked you all to do just now, and each group, don't forget to submit your group score to me personally. Alright, so now let we discuss the quiz activity together. Alright, okay, for the quiz questions, it's obvious. The answer is circumference. Okay, for the next question, so for this question is straight line pass through the center of circle. We call it diameter. And next, a straight line that only connect between the center of circle to the circumference, we call it the radius. Okay, next. Right, this question might seem new to you, or if you recall back, the answer is tangent, because a straight line that touches the circle at one point is called tangent. Next, so for this answer, as you know, it's obvious. No, it is chord. Alright, next. So for this, as I explained just now about the minor sector and minor arc. So this is the arc. Okay, for this, the answer is segment. Okay, for this, I taught you all just now, which is sector, and this sector is, we call it minor sector, right? Okay, for this is the center or the center of circle. Next, as you can see, this is the half of the circle, so we call it the semicircle. Right, so 10 out of 10, how many score that your group have? Okay, let's continue our lesson. So as you can see that there are 4 angles in the figure, and I'm going to label it E, F, G and H. Okay, so as you can see that the angle of EFG and EHG are from the same arc. So we can say that angle at circumference subtended by the same arc are equal, which means that the angle EFG and EHG are the same angle. Alright, next, how about angle FEH? Since angle FEH are also same arc to the angle FGH, therefore these two angles are the same. Alright, next we move. Alright, let's go to the example 1. As you can see from the figure, the question is require us to find x. So let's solve this together. Alright, so from what we have learned just now, that the angle of circumference subtended by the same arc are equal. So from this question, we look at this arc. Alright, so from this arc, there are 45 degrees from this arc. So we know that this angle is 45 degrees. Alright, next we're looking at this arc. So from this arc, the angle from this arc is 30 degrees. So automatically you know that this angle is also 30 degrees. So now, how do we find x? So in order to find x, we need to find this angle. Alright, so the total angle of triangle is 180 degrees. Therefore, we use 180 degrees minus 45 degrees minus 30 degrees equal to 105 degrees. Therefore, to find x is 180 degrees minus 105 degrees equal to 75. Okay, next. Okay, alright class, so we move to activity 1. So in this activity, the aim is to verify that angles at the circumference subtended by the same arc are equal. So which means that in this activity, we will be verifying that the angles from the same arc, either it's equal or not. So the materials are A4 papers, compasses, protractor, ruler and pencil. So for the steps, for the first step, draw a circle of radius 5 cm. So you may take out your ruler and draw a straight line of the radius. After that, you might use your protractor to draw a circle. After that, draw a chord PQ based on the diagram 1. Chord PQ. So in step 2, draw a chord QR that form 30 degree at point Q. So on step 2, you might use your compasses, put at the point Q, measure the angle of 30 degree and draw a chord QR. Then other groups are encouraged to form acute angles between 20 degrees and 40 degrees, which means that this activity are group activity. So I want each group have 3 members. Okay, so we move to step 3. Mark the point S on the circumference and draw chords PS and RS based on the diagram 3. You can see, mark the point S on the circumference. You might mark any place of the circumference, because on this activity we just to verify the angles at the circumference subtended by the same arc, whether it's equal or not. So then that's not necessary to follow the diagram. You can just mark it any point, right? So after you mark and draw the chord, you move to step 4. Measure angle PSR and record it in the table below. So after you draw the chord and you measure the angle, whether it's same 30 degree from angle PQR, just record it here on this table. Then we move to step 5. Repeat step 3 with point T and chords PT and RT based on diagram 4. So on this step 5, you mark the point T and draw the chords. After that, measure the angle PTR and record it in the table. So you have to measure it also and record the angle on this table. On the last step, you may repeat the step 3 with other points on measure arc PR. Measure the angle formed and record it in the table. So in this step, you can add another marking point. So you can, after you mark the S and T, you can mark it here or at here to verify that all the angle in circumference subtended by the same arc are equal. Alright, for the first step, require us to draw a 5 cm radius. So take out your ruler and draw a straight line of 5 cm. After that, take out your compasses and draw a circle of 5 cm radius. Then for the next step, require us to draw a chord. So you might not need this radius anymore. You can just erase it. Alright, so for draw a chord, you can choose any point to draw it. So take out your ruler, make sure your chord are straight. So draw a chord, and then next step require us to draw angle of 30 degree from this point. Therefore, take out your protractor and make sure the reading are from the right side from this line, because we're measuring from this angle. So 10, 20, 30. Alright, here's the 30 degree. So draw a straight line from here. Alright, so label this angle 30 degree. And so don't forget to label your point P, Q, and R. Alright, next is require us to draw point S. So you can choose any point, doesn't necessary to follow the diagram, alright? So you can choose other point also can. So draw it from here and must make sure that the angle are, the line are from the same arc, and also draw for the third point and label it S and T. So now we're gonna verify the angle PSR, PTR, whether it's equal to the angle of PQR, since those three are from the same arc. So in order to verify this, I have to measure the angle here and here. So I have to take out your protractor. Alright, so measure from this angle, reading from the left side here, starting from 0. Okay, so from this reading is 30 degree. Therefore, angle PSR is 30 degree. How about angle PTR? So take out your protractor and measure from this point. Okay, so from this angle also 30 degree. Therefore, label it 30 degree. So, and don't forget to record the reading into your table. And from this, we have verified that the angle of PQR, PSR, and PTR subtended by arc PR are equal. As you can see, all the angles are equal from the same arc. Therefore, angle PQR angle equal to angle PSR and equal to angle PTR. So we can also repeat the step 3 just now, which is draw any point from here or here, or from any point of the circumference, to verify that the angle from the same arc are equal. So next is the angle at the circumference subtended by arc of the same length are equal. So based on this figure, if the arc has the same length, therefore the angle subtended are equal. Let's go for the example. Okay, as you can see that the angle is 30 degree and the arc is, both arcs are the same length. So angle at the circumference subtended by the same length of arc are equal. Therefore, x is 30 degree. So next, okay, so let's look on these questions. This degree is 25 degree, and from the same length of arc. Therefore, x is 25 degree. Alright, so how about these questions? Okay, so as you can see from these questions, we only look for the same arc. So from the same arc of x is 10 degree. So x is equal to 10 degree. Alright, let's look at this figure. So the size of the angle at the center of the circle subtended by the same arc is twice the size of the angle at circumference, which means that the size of angle at the center here is double the size of the angle at circumference. Therefore, the value at the center will be 2x, and the value at the angle at circumference will be 1x. Okay, how about this? Also the same thing, the size of the angle at the center subtended by the same arc is twice the size angle at circumference. So no matter how it moves, also the center will be twice the size. Therefore, the center will be 2x, and the angle at circumference will be 1x. Okay, next, this is also the same situation. So also the angle at the center is twice the size of the angle at circumference. So that's all. Thank you for watching. Alright, please smash the like buttons if you like this video, and also don't forget to watch part 2, in which we'll be doing some exercise or activities and discuss the past year exam questions.